This is my project for machine learning, and I decided to make a rainfall prediction project. This is the overview of machine learning. It's basically a subset of artificial intelligence which focuses on developing algorithms that allow systems to learn patterns and make decisions or predictions without explicit programming. This is the significance of machine learning in my project. We are going to use machine learning techniques like unsupervised learning, supervised learning, and reinforcement learning to make sure that we feed data into the model and make it learn so that it can predict the amount of rainfall, and maybe we can be able to be well prepared of the amount of rainfall that you're going to receive and when it's going to come. The problem statement of my project is this. The project aims to address the challenge of accurate and timely rainfall prediction, a critical aspect in weather forecasting. The existing methods often encounter limitations in handling complexities of weather pattern handling to suboptimal predictions. So, with machine learning, we'll be able to improve the timely and accurate predictions of when and how much or how heavy rainfall is going to be. This is supervised learning. As we know, supervised learning is a type of machine learning where a model is trained using labeled data sets, which are used to map inputs to outputs and hence make predictions for new data. Unsupervised learning, we will know very much that we use unlabeled data sets. Therefore, the algorithm try to identify patterns and structures for relationship within the data without explicit guidance. And then reinforcement learning, here a model is given a reward when it predicts well, and when it predicts falsely or it fails to predict accurately, it's given a penalty and hence it improves its performance. Supervised learning with a concept with example is a spam, the system which allows the email to filter out spam emails and non-spam emails. It uses supervised learning where labeled data sets, one data set is labeled as spam and the other is labeled as not spam, which enables the system to do what? The system to classify those emails. The applicability in my project of supervised learning, supervised learning can be applied to predict the amount of rainfall based on the historical data. Then the algorithms and the models, we are going to use linear regression, decision trees, and ensemble methods like random forecasts are suitable for predicting continuous values of rainfall amounts. Then the type of problem we are solving here, supervised learning in this context addresses the regression program predicting continuous and progression, predicting continuous values of rainfall. The utilization of the labeled data. Labeled data consists of past weather conditions paired with the observed rainfall, and the model uses data to learn the relationship between the features and the rainfall amount. Then we come to unsupervised learning. Here the examples we can use, we can use clustering to group similar weather patterns together without prior labels. The application, here we're using clustering to identify distinct weather patterns, aiding the understanding of variation in atmospheric conditions. And the algorithms and the techniques we are probably going to use clustering techniques like K-mean, hierarchical clustering, and dimensional regulation methods. Types of insight or patterns. The goal is to identify the natural groupings and the coloration within the data, helping to reveal the different weather patterns that may contribute to rainfall variabilities. Here we also have handling and handling of unlabeled data. Unlabeled weather data, including variables like temperature, humidity, is processed using unsupervised learning techniques to uncover the inherent structures and relationships. Then we come to reinforcement learning. Reinforcement learning, a definition, it involves an agent learning by interacting with the environment. Here the agent takes action and receives feedbacks in form of rewards or penalties. When a system predicts well, it's rewarded, and when it predicts falsely or it fails to predict accurately, it's given a penalty, so that next time it should improve its performance. Integration in a project. Rainfall prediction systems. Reinforcement learning is applied to make decisions in the decision making process. The environment is the atmospheric condition, the agent is the model making decision, and the reward system encourages prediction, leading to effective decision making. So that's the environment, it's atmospheric conditions, and the weather data. The agent is the rainfall prediction model, and then the reward system gives accurate predictions, reward and penalty for inaccurate predictions. Yeah, this is the comparative analysis for these machine learning techniques. For supervised learning, it's this for the strength, it's effective for predictive leveled outcomes, e.g., emails or rainfall amounts. Then the limitation, it requires labeled data, and there might be struggle in complex patterns. Then the preference in projects suitable for predicting rainfall amounts based on the historical data. Then for unsupervised learning, the strength, it discovers patterns without labeled data, useful for exploring the complex structures. Then limitations, there is a lack of explicit guidance. Then the preference in the project, it's applied for exploring the underlying weather patterns and structures in absence of labeled data. Then in reinforcement learning, the strength, that's the ideal of decision making process. It learns from interacting with the environment. Then the limitations have the complexity in designing the reward system, and it may also require extensive training. Preference in project is useful for optimizing decision making in dynamic changing weather conditions and adapting predictions based on the real-time data. The method preferences for supervised learning, they are preferred for predicting specific outcomes such as rainfall amounts, where historical labeled data is available. Then unsupervised learning, applied for exploring underlying patterns, structures in absence of labeled data. Then for reinforcement learning, it's useful for making decision and dynamic adjustment of predictions. These are the use cases for unsupervised learning, and finally for reinforcement learning. Then I have the challenges and considerations: data quality, computational resources, have ethical consideration and biases in data, And then finally, this is our conclusion.